Hello everyone, welcome to my session on object-oriented programming in Java. The agenda for today's session are the features of object-oriented programming. So we'll be covering classes, object, polymorphism, abstraction, encapsulation, and inheritance. These are all the features of object-oriented programming, and these are what we are going to cover in today's session. The first session is on class and objects. So let's start with classes and objects. So what is a class? A class is the core of Java, and a class is the template for an object. Not only the core of Java, it is also the core of any object-oriented programming language, because any object-oriented programming language has to have a class. A class is actually the template because it gives us a structure. A structure in the sense a class name with curly braces, inside which we define the variables and the function is the structure, minimum structure. And then only with the objects. Again, we have to create objects over there, and with the objects we can access the variables and the functions defined inside the class. So that is why the nature of the object depends on the class, and that is why it is known as a template of it for an object. Here, every class defines a new data type, and once defined, it can be used to define objects of that particular type. So each and every class is like a data type, and each and every object is like a variable of that particular type. Now we'll come to what is an object. An object is an instance of a class. What is meant by instance? That is, it's a reference for a particular class. So when a variable of a class is declared, it is just the reference. This just refers it. It doesn't get any memory. It is not an object. It doesn't provide any memory space. But when an object of a class is created, only when the new keyword is used. That is when and how it is done. That is how is the memory allocation made possible. I'll show you clearly with an example. Just consider there is example of an account class. Here, account ACC is just the reference of the account class. That is, you're just giving it the reference over there if you declare it this way. But then when you say account ACC equal to new account, that is when ACC gets memory allocated. That is allocation of memory allocation for that particular ACC object happens only when you use the new keyword. It is then that ACC becomes an object. Otherwise, it is just a referral object. Now we'll come to the second topic, that is second feature, this polymorphism. So what is meant by polymorphism? Polymorphism, the word itself, poly means what? Many, and morph means what? Forms. So polymorphism is existence in more than one form. Now let it be the life cycle of a butterfly. It shows many forms in the life cycle and different roles that a woman plays. At different time, she is a different person. That is, she has to be a daughter, she has to be a sister, she has to be a wife, then she has to be a mother, a professional. All these times, she's playing different roles. So this is a very good example for polymorphism. Real life examples. But then overloading is compile time polymorphism, and overriding is runtime polymorphism. That is, overloading and overriding is something through which polymorphism is made possible in programmatically. So overloading is again functional overloading and constructor overloading. And we'll come to what is overloading and overriding and all in the detailed sessions. Now we'll come to abstraction. That's the third feature. Now what's abstraction? As the word abstract, what's abstract means? Something in a short form. Same way, abstract over here also. Here you just see two diagrams. You can have two cars over here. One car the first one, its complete form is using abstraction. The other one where the engine is open is without using abstraction. So abstract means it doesn't give a complete picture. So here in the first diagram, we know that here the engine is placed over here, but we don't know what is the working of the engine or the mechanism inside it. The functioning is not known to us. So here, using abstraction, we are hiding things. It's not seen. Complete idea is not provided of the function. Complete idea is not at all provided using abstraction. But without abstraction, we are giving a complete idea is being, everything is shown out. So that is what is abstraction. Without abstraction, how it works. Here again, abstraction is implemented using abstract classes and interfaces. And a polygon is a very good example of abstract class. In a polygon, you can consider the example of a polygon. We have many number of sides, but we don't know. We can't define find area in a polygon because the number of sides is not known. So formula is not known. So we can't define it over here. But so it's where we can't define such things. Method is abstract. A class is abstract. We can define it as abstract. And then in subclasses, whereas in the when you come to the subclasses like square, rectangle, triangle, and all, we know the formula, we know the number of sides, so you can find the area over there. And so find area can be defined inside the subclasses. So that is where we can implement abstraction properly over there. Now, when I come to the next topic, that is encapsulation. So what is encapsulation? What does the meaning of encapsulate means? Here, encapsule. The word meaning itself, and a capsule means what? Something, the medicines with a boundary. So a cover is there, it's wrapped in with the granules inside it. The same way, a class can be considered as a capsule with a curly braces, a boundary is set, and then it contains variables and methods, and these variables and methods can be accessed using objects. So here, when these variables but then that is what is when the real life example which I can give you. But then how is it implemented in our program, Java program? Here, it's visibility. That visibility of the variables and the functions can be decided by using access specifiers. So it is implemented. Encapsulation is implemented using access specifiers. And what are the access specifiers? Private access specifiers, default access specifiers, protected and public access specifiers. So these are the specifiers, and depending on it, which specifier we are using, that is which access specifier we are using, the boundary of the variables, till where these variables and these functions can be accessed, this can be limited. So that is what is encapsulation. Next, we'll come to inheritance. So what is meant by inheriting? Here, inheritance means nothing but the parents have certain features. These features of the parents are inherited by their children, and some additional features can also be acquired by them. So same way in object-oriented programming language also, inheritance that means nothing that base classes or the parent classes have certain functions and features in them, and these functions and features can be accessed by the subclasses or their child classes, and then additional features or functionalities can be added into it. This is what is inheritance, and we'll know more about it, more about all these features in the detailed sessions. So thank you for attending our session on object-oriented programming in Java.